Namaste students, I am JVN Dr. Aziz Mohammed Khan from Department of Food and Biotechnology, Faculty of Agriculture and Veterinary Science, Jyoti Vidyapeeth Women's University, Jaipur. Today I am going to discuss about the topic Introduction to Yield, Conversion and Selection. So, fraction, conversion, yield and selectivity are percent excess are all important method of describing how a chemical reaction progress. So, it is a chemistry topic basically, and they are useful values to solve material balance. First we discuss about the conversion. What is the conversion? So, conversion is defined as the number of moles of a compound that reacted divided by the amount of moles that were fed. Means if we are doing any reaction, then in any reaction the number of mole that is V that is produced divided by the amount or the moles we have added, total volume that we have added is divided. So fraction conversion and consumed input and fractional conversion and consumed input are divided to each other. Another useful form of writing fractional conversion is that fractional conversion is equal to an input means we have we added the amount minus an output means the amount that was out after production of any product. So after minus we divide this value by the input amount that was the initial amount. So it will show the percentage of the conversion. And we can take the example of NH3 here. In a reaction, and when we performed the NH3, then the conversion of NH3 can be calculated by the amount of NH3 that was consumed, okay, and the amount of NH3 that was added. So if we divide the amount of NH3 consumed from the amount of NH3 that we added in the starting, then we can calculate the conversion. And how we can calculate the amount of NH3 consumed? The amount of NH3 consumed can be calculated by subtracting the amount of NH3 in sorry, the amount of NH3 in minus the amount of NH3 out. So we can calculate the NH3 amount that is consumed, or using this NH3 consumed we can calculate the conversion. The next is yield. The yield of reaction is the ratio of desired product formed in moles to the total amount that would have been made. Means it is a total yield volume. If conversion of limiting reactant was 100% and no side reactions occur, yield is defined as the moles of product formed divided by the ideal number of moles formed. So in the usual thing, we can calculate the yield by dividing the moles of the product formed from the ideal, that is the calculated moles. The ideal number of moles is already calculated, okay, it is standard, and the product formed is our actual volume of a product is 100, and we have isolated the 80 volume, then we can calculate the yield by 80 divided by 100. So it is a yield, total yield. So yield is can be calculated by the amount of NO produced divided by the maximum amount of NO that would be produced, that is actually produced or that can be produced. So it is a standard and it is our actual produced volume. So it is a simple thing that is used in the industry. Now we discuss about the selectivity. What is the selectivity? Selectivity is defined as the moles of desired product formed divided by the moles of undesired product, because selectivity can be is also necessary because sometimes we want some product and we isolate some undesired product. So selectivity calculation is also necessary because selectivity will tell us that how the downstream processing is required to removal of undesired products. Desired divided by selectivity of reaction is the ratio of desired product formed in moles to the undesired products formed. So the formula is using the NS3 example. The formula of NS3 selectivity can be the amount of NS3 consumed in a reaction divided by the total amount of NS3 consumed. So our lecture is over here.